when trying to properly support your part. There are many reasons to go back and recut your soft jaws. For example, your jaws might be worn or damaged. Or maybe your parts are beginning to creep out of tolerance. Andrew plans to reuse the jaws that were originally cut to hold our bearing housing part. Since he knows that he'll be using these same jaws on this same machine with this same chuck in the future, there is no need to recut. Before disassembly, he finds a mark or feature on the master jaw and scribes a line on the soft jaws to locate them at this exact tooth position in the future. Then, as he removes each jaw, he numbers it to match the number of the corresponding master jaw on the chuck. In this way, concentricity will be maintained without cutting the jaws again. Andrew packs his jaws away and powers down the machine. As anyone who's worked in a machine shop knows, tooling sometimes has a habit of disappearing at inopportune moments. Andrew needs to run this bearing housing again, but he's found that his jaws have been used on a different machine in the shop. After finding and retrieving the jaws, he needs to recut them before he can run his parts again. Using the scribed reference marks, Andrew mounts the jaws in the exact same position as they were before. Since the idea is to machine away material to correct the jaw inaccuracies, we need to clamp OD gripping jaws to just slightly smaller than the workpiece outer diameter. Conversely, ID gripping jaws should be positioned just slightly larger than the workpiece inner diameter. We will use our part to set the initial position of the jaws as they clamp the boring ring. We want to check what diameter the jaws are actually positioned at. To do this, we program a simple move going to X0 with the tool and offset we'll be using to recut the jaws. Press hand jog, press current commands, and press page up until you reach the position page. With X-axis selected, press origin to zero out the operator position field. Now that we know where X0 is for tool 1 and offset G54, let's find the jaw face diameter. Jog to a point very close to the face of the jaws. Use a slip of paper and bring the tool to the jaw face until the paper is pinched by the insert tip. The X-axis operator field now shows us the diameter that our jaw faces are set to. In our case, we want to recut these jaws to the nominal part diameter of 3.950 inches. With our jaws checked at a clamp location of 3.935, we have set their position such that an adequate amount of material will be removed from each jaw face. We will also change our jaw cutting program to skim cut into the back face, 10 thousandths deep, to clean up this face as well as the main bore. Always skim cut the jaws for complete cleanup, but keep material removal to a minimum to get the most life out of your jaws. Now they are the correct bore size and once again concentric to the spindle. When clamping force increases, so does the deformation of the jaws. For this reason, when cutting soft jaws, it is important to try and use the same holding pressure that will be used when machining the production parts. When the pressure needed to hold the part is much higher than the pressure that was used to cut the jaws will deflect away from the part, particularly at extreme differences in clamping pressure and at very long jaw lengths. To compensate for this deflection, cutting a slight taper in the jaws may become necessary. After the taper is cut and the correct force is applied to the workpiece, the jaw faces will still be parallel to the workpiece despite jaw deflection. Let's look at some real-world scenarios. This set of short steel jaws was bored to 1 inch deep while being held at 100 psi. When we clamp this accurately machined slug at 300 psi and check for deflection, we find that we can't insert even a 1/1000th of an inch feeler gauge at the jaw tips. Next, we have these short aluminum jaws cut with a 1.5 inch deep bore, also at 100 psi. Again, we clamp the machined slug at 300 psi, and although you might think, with the softer material and different clamping height, we might see significant deflection, we still can't get the 1/1000th of an inch feeler gauge in between the jaw and the workpiece. To demonstrate a more extreme scenario, we move on to these tall 4-inch aluminum jaws, which were bored very deep at a clamping pressure of only 50 psi. When we clamp the demonstration workpiece at a pressure of 400 psi, jaw deflection becomes significant. Let's find out just how much taper should be added to the jaw bore. Andrew measures the space between the deflected jaw and the workpiece using the feeler gauges. He finds a 4/1000th of an inch space, so he will start by adding a 4/1000th taper to the jaws. For both outside holding and inside holding jaws, you should cut the taper to leave more material at the jaw tip than at the jaw base. Going back to his original program, Andrew changes the starting point of the cut from Z0.05 to Z0 to start right at the face of the part. He inserts U0.008 in front of the Z depth move. This will taper the face so the bore is larger diameter at the bottom than at the top. Since U0.008 is a diametrical adjustment, it will taper each wall 4/1000ths of an inch. Andrew cuts the taper in the jaws. With the taper cut and the workpiece clamped at full pressure, feeler gauges will probably not fit in the remaining space. However, there may still be a small gap. Now, Andrew uses a slow-drying, bluing compound to check if he needs to make another slight taper cut. He clamps the workpiece in the jaws at full production pressure and applies a coat of the compound to the edge of the jaws where they meet the workpiece. After allowing the bluing to dry, Andrew unclamps the jaws and finds that very little of the compound has seeped in between the jaws and the workpiece, not even where the jaw tips contact the workpiece. This indicates the jaws are gripping along their entire length. Now let's look at what too much and too little taper look like using our setup. 1/1000th of an inch too much taper results in a concentration of bluing at the base of the workpiece, indicating the jaws are not contacting in this region. The inverse of this is 1/1000th of an inch too little taper, which results in good contact only at the base of the jaw, where it meets the workpiece. In either case, another pass can be made to either remove or add a slight amount of taper, and thereby achieve the correct engagement. Thanks for watching this video, and stay tuned for additional episodes covering other machining fundamentals.